Hello everyone, welcome to OdinSchool. Today we are going to learn about the most important component in the data industry, statistics. We are going to learn an advanced level of statistics in the coming classes. To begin with, we are going to learn about the three core components that one must know in order to perform any type of analysis in statistics. The core components are sample, population, and probability. Learning these concepts help someone to choose what type of analysis can be done and what type of analysis cannot be done on the given data set with a given problem statement. So it becomes really vital for anyone to understand what is a sample data set, what is a population in data set, and what are the different types of probability that one must know in order to answer a business question. We are going to learn about all these three concepts with a lot of examples in it. First, let's get started with the basic question. Why should someone learn statistics? Statistics is one of the most widely used operation or a metric or a subject in both real life as well as in business. Assume you wanted to go buy a t-shirt in a shopping mall. Your budget is $1,000. You go there, you find an amazing t-shirt, you use a trial room to check it out, and everything is fine. You are completely you completely wanted to buy this t-shirt, but once you see the price tag, it says $1,500. Now there is a deficit of $500. Now in this case you will have to take up a decision. Either you should buy a t-shirt less than $1,000, or you should not buy the existing t-shirt that you liked. Now this decision making process happened through numbers, quantitative output, and this is helped by statistics. Not just buying a t-shirt, almost every decision that we make in life is some or other way related to numbers. Anything that is related to numbers has to be performed with a certain set of statistical measures. To give an example, mean, median, mode, what will be my percentage, what will be my percentile, all of them are statistical measures only. So knowing statistics not only helps your professional career in the field of data industry, also helps you personally to take up better decisions. It is very vital to learn statistics, and hence we will learn about the advanced concepts in this complete classes. First, let me quickly introduce about OdinSchool and about myself as well. OdinSchool is a technology upskilling platform. They help you continuously acquire new skills. Their motto is to stay skilled and stay ahead. About me, I'm Gautam Kumar Jayachandran. I have 6+ years of experience as a senior data scientist, and I work with several technologies starting from Excel, SQL, Python, Tableau, machine learning, and Analytics. I also work with several domains. Currently, I work with finance. Now let's see today's agenda. We are going to see what is population, what is sample, and what is probability. All these three are very basic yet very important concepts in the world of statistics. Now, first let's understand what is population. A population is simply nothing but a complete data set, a complete entity. It is the every member of a group. Now, let's see examples. That way we can understand this better. Let me take a data set. Yes, perfect. So this is my entire data that I have. Okay, this entire data set that I have is, I'm just going to maximize this. I'm just going to copy this, put it in a new file so we can play with this. Okay, that's fine. It doesn't seem to work. So let's keep in the same data sheet only. Let's keep it in a new sheet. Perfect. We have this information now. 125. Zooming this in a little. Now see here, this is a data set that belongs to some business, some business that happened, and some client might have given this data set with a problem statement. A problem statement is simply nothing but the area where there is a concern for the business owner, and he might not be able to rectify it, so he might have come to us as data scientist and data analyst to help him or her resolve the business problem. If you see here, we have 106 or 105 line items in total, 105 rows excluding the headers. So this is my entire data set. Now the business problem might be the problem statement. Let's create our own problem statement here. The problem statement might be, what is the product Sunshine performing better than the product Velata? Now this is the business question that the owner is having, the business owner or your client is having. Now they may not be able to understand this data completely, because as a human being we will not be able to consume every raw number that is there here. Even if I take the first 10 line items, it is too much for a human being to understand each and every line item of sales here and proceed to perform some operations to optimize the business. That is not how it works. So rather what we will do is, we will work on calculating things. As a business analyst or a data scientist, you will do the operation. You know what is the business problem. What is it? We'll have to compare the sales of Sunshine product with the product Carlotta and say what is the output out of it. To do it, what I'll do is, I'll calculate three different things. Sunshine Carlotta. I'll first calculate the total sales in both the cases. I will calculate the total number of sales. I'll simply say number of sales. And then I will say average sales. Okay, let's calculate this. If I'm using the product range this, and my criteria is this, and my sum range is sales. It gives you sales. Look at this. By overall sales that happened in both the products, we can assume that Sunshine is actually not performing better than Carlotta. Carlotta is performing better than Sunshine. But this is just the total sales. We cannot come to any conclusion without calculating several types of statistical measure and comparing them with each other. Then I will try to see what is the total number of sales that happened in both these products. First thing is, I'm taking COUNTIF, where the range will be the product here. I'm taking the product, then I'm taking the range here, criteria here. That's all I have to do in this case. I'll simply do the same thing here. Look at this. It is very clearly evident that even after selling 25 products, 25 times Sunshine was sold, even after selling it for 25 times, we have very less sales compared to Carlotta, where Carlotta was able to generate more sales by selling less number of products. Clearly, Carlotta is outperforming Sunshine in this case. Now let's calculate the average as well. Now to calculate average, I can simply use sum divided by count. In this case, this will be my dollar symbol. Same happens for this case as well. Now we can go ahead and say to the business owner saying that, sir, Carlotta is actually performing better than Carlotta is performing better than Sunshine in all the aspects of business. Clearly, Carlotta is actually generating more profit to the business than Sunshine, because Carlotta, the number of sales is very less. Even though the number of sales is very less, it can actually generate a more revenue. Whereas Sunshine, even after selling more number of products than Carlotta, it cannot generate more revenue than Carlotta. Clearly, the Sunshine's average is very less than Carlotta's, with whereby we can confirm or inform the business owner or the client, stating that Carlotta is your business winner. You should focus more on improvising Sunshine because Carlotta is actually performing better than Sunshine. Now, to come to this conclusion, what I did was I took the entire data set. We know that we had 105 line items starting from the first row, second row till 106th row. We have 105 line items. The entire data set is considered in this process to calculate and see what is the value that we will generate out of the population. This is our entire population. I did not do any subsetting operation. I've just taken the entire data set and calculated this statistical measure to come up to an understanding. Since my data set is only 106 105 rows long, it is very small, very tiny data set compared to what we will see in real time. Since we have very less volume here, I am able to consider everything to generate an output. But in real time, what happens is we have huge amount of data. To just give an example, this is actually a fact. Amazon and Flipkart in India generates 8 TB of data per day. The data that we have here as a table is hardly less than a MB. But in real time, Amazon and Flipkart only generates 8 TB of data per day, which is a huge number, huge volume of data. In that case, if the user is having this particular problem statement, we will not be able to perform the statistical measure like sum, count, average in the entire data set, which is very expensive. If I'm performing these operations on the entire data set, 8 TB of data, let's list out what are the challenges that we have. We need huge hardware requirement, because your hard disks has to be as big it should be, because every day if you have 8 TB, you need to have huge amount of hardware to store this data in the first place. Then even though if you have good amount of hard disk, you need good amount of RAM memory to process this data to perform even the summing operation. Even if I wanted to perform the total value, I need huge amount of RAM, because the RAM defines how better it can perform calculation basis your memory. So you need good hardware requirements, which are very expensive in nature in terms of money, and the time it will take to perform operations on the entire 8 TB data set again will be time expensive. You need to spend so much of time in calculating or in performing any small tasks. Assume you wanted to perform a bigger task, then the time will be even more longer than the regular time that it will take for smaller operations. These are three different things. On top of that, you need more manpower also, because this is a very small data set. I can process everything, I can do the calculations. I as a single human being can do the calculations, but when I have 8 TB of data, I'll partition this data into 8 1 TBs, and I need 8 individual person to work on the problem statement simultaneously and try to combine them together. It requires actually a team to process this amount of data. So whenever you have huge amount of data, then it is a concern for companies, because they need storage devices, they need high-end computers through which only we can process the calculations, and they need more time, they need more money, they need more manpower. This is the challenge with dealing with population data set. So what we will do is we will go with something called as sample. The idea is sample. Now what we will do is we will subset the data from the population randomly. We will not take okay, give me the first person in the population, give me the third person, give me the fifth person. We will not take any pattern. we will randomly subset the population and calculate the same operations, same perform the same operations, sum, count, average, any other statistical measure, standard deviation and variance also. In that case, what happens is the subsetted data will give an output which can be used to infer to the population. That is the idea of sample and population. So in real time, if you ask me whether you will use population or sample data set, in most of the cases the answer is very simple. It is going to be sample only. We will use very in a very less instances we will be going with the population data set, because it consumes so much of time, hardware, money and resources. Whereas in sample we can take the data, we can take a subset of the data and perform the calculations. Now what I'll do is I'll do the same operation like we did this operation, right? We are going to do the same operation here, but to answer the same problem statement, rather than considering the entire data set, I'm going to create a subset of it. Let me create a subset here and paste it over there. I'll just create some numbers for randomization. I'm going to randomly pick. I'm not going to follow any pattern whatsoever. 105. Okay. Um, I'm going to pick like 50 percentage of the data, not even 60. I'm just going to pick 50 percentage of data here. Let me see if I have duplicates. 9 duplicates were there. Now we have 44 data points. Let's add more data points also here. Let's add a few more. 1 to 105. Perfect. So we don't even need 59. So what I'm going to do is I'm going to take 4 out of it. Now how many do I have? I have 55 data points, but 53 or 54 is enough to give 50 percentage. Now I have 53 data points. Okay. I'm going to randomly subset these data points from this population using extract filter. I'll just copy this somewhere else. There's my criteria range. Yeah, I would like to copy the records here. Yes, it has randomized it has subsetted the data. Let's see how many data points we have here. Look at this. We have 105. Why did it give me 100%? 1 second. Yeah, there's a mistake in the filter. I'll take you. I'll just copy this somewhere. Now this should work fine. Yes. Now look at this. In this data set, we have only 53 line items, whereas in my population, I have 105. Out of 105, I've taken 53. What is the percentage share that I've taken? Let me show you that also. Percentage share. The percentage share is 53 divided by 105. 50 percentage of data is what I have taken to generate this output. That's my big pen. Yes. So it's going to be a percentage. I've taken 50 percentage of data from the population. Okay, I've not taken more, I've taken only 50 percentage. Now let's get this data back into the sheet and calculate the same analysis in this, in that particular use case. Okay, we have this information. I don't want this random information. Yeah, now let's calculate the numbers. I'm going to copy this so that I can recreate the same using my pop sample data set here. That is for my population and this will be my sample. Now let me delete everything, calculate things from the beginning. Sum of product, my range is this and the criteria is this, and the sum of, same happens for Calata. Then talking about sales, I'll simply count if the range, this is my range. And talking about sales, I can simply use sum divided by count. See here, even in this case, it is very clearly evident. We don't have to have the concept of population to understand the business or answer a business problem. Rather, what we can do is we can take the subset of the data and still perform an analysis which will infer very close to the population. Now let me show you with examples. Yeah, this should be fine. Now if you see here, in this case, the average of sunshine in the sample is 614, Carolata is 1005. Look at the population. It is 658 for sunshine and Carolata for it is 903. In both sample and population, my answer will remain the same. Carolata is outperforming sunshine in all the aspects of sale. What did we do here? We randomly subsetted the population. We did not follow any procedure here. We randomly took certain data points from the data set and calculated the sum, count and average to see what will be my answer to this business problem statement. The problem statement is understand whether try to compare between Carlota and Sunshine and tell which product is performing better. In population, when we performed this operation on population, Carlota was outperforming Sunshine in all aspects of sales, in the total, in the count of sales, in the average of sales. The same happened here as well. Even if you see the sum of sales, Sunshine has sold for only $9,000 despite selling 15 times. Whereas by selling only 10 times, Carlota was able to achieve $10,000, which looks like, if you see the average sales of Carlota is $1,000, whereas here in Sunshine it is 614 only. Clearly, Carlota is outperforming Sunshine even in the sample data set which is randomly picked. So in real time, what we will do is we will rather than performing the operation in the population, we will do the operation in the sample. That way we save a lot of time, resource and money in understanding the business. Now you must also understand one more thing. You cannot say that the sample will always refer to the population. No, that is not how it works. Sample will try to infer to the population as closely as possible, but doesn't mean that it will be the same. Look at this. I have taken 614. The average sales in Sunshine is 614, whereas in the population it is 658. In Carlota, the population sales average sales for Carlota is 903, whereas in population in the sample is 1005. Now in this case, we must understand that these values are close enough, even though they are not exactly the same. These values are close enough to understand the context to the particular business problem. So that is exactly where sample and the population comes into picture. Without sampling the data, it becomes really tough to process the entire population and derive an output out of it. So that's why we need to know the concept of sample and population. Now that we know it, in the very beginning, I told you that only basis understanding what type of data that we are taking, whether it is a population data or sample data, we will be able to decide what type of analysis has to be done on the data set. Now in this case we have performed sum count average basic statistical measures. Now what if I wanted to perform standard deviation and variance? Standard deviation, variance. I'll just copy this here. These two are very important metrics in real life, standard deviation and variance. Now see, if I wanted to perform standard deviation on the population data set, there is a different function for it. If I wanted to do it on the sample, there is a different function for it. So that's why you need to know what is the data that you're handling, whether it is the sampled data or it is the entire population. Basis that even the smallest function like standard deviation differs. Now let me calculate standard deviation for sales. It will be the same. We cannot perform standard deviation basis a condition, so standard deviation is going to be the same. Variance also depends on the population and sample. There are two different formulas for both variance and population, variance population and variance sample. You cannot use variance population function on a sampled data set. So that is why it becomes really essential for us to know what is the type of data that we are dealing with, and basis that we will choose what will be our metric will be. See here, in our population the standard deviation is 406, 404, but in my sample it is 406. To calculate variance, I'll use variance as sample, not variance population. Look at this, variance in my population is 16,3609. Variance in the sample is 16,5182. Looks like the numbers are very close to the population, even though we have taken only how much of data? We have taken only 50% of the data. See here, we have taken only 50, even if I round it, it will be 50% only. I've taken only 50% of the data here to calculate and understand the business problem, and my business problem produces me a result as closely as it will produce in my population. This is the power of sampling. But the one thing that we need to keep in mind when we are performing random sampling is the more the sample is, the more better it is. That is the simplest idea. There is no certain rule saying that you need to have 70% of sample, 70% of the population, you need to have 80%. There is no certain rules in it, but the ideal numbers that we will take in market is 60 to 80%. If you have 60 to 80% from the population as your sample, then there are good chances that your output will be as close as it can be to the population. So I always go with 70-30. 70% I will keep for sampling, 30% I'll keep for testing. That way it will be easy for us to understand how the data is distributed and how it can be used and what type of analysis can be performed on the data set. This is the idea behind sample and population. Let's go on to the next one. The next one is going to be posterior probability. Okay, posterior probability. First, let's understand what is prior probability. Then we will understand what is posterior probability. I think next we are going to learn about total probability rule. Yes. Okay, first let's understand what is posterior probability. Posterior probability, let's first see what is the theoretical understanding. It is basically a probability of an event, that the probability of the event is computed before the collection of new data. It is as simple as that. Example is, if 5% of the population has car, then the probability drawn at random would be say for an example, the basic statistics or the fact that we have is somewhere around 5 years back there was a census taken. Okay, that census says 5% of the Indian population owns a car. Okay, that is the understanding now. Now, what will be the probability that someone randomly picked, someone is going in the street and you are randomly stopping him and asking him, do you have a car? What is the probability that that particular person will have a car? Only 5%, because that is the actual data that we have. But the census might be a little outdated and there might be things that might have grown above and well and above. Now the user says there are only, even though there are only 5% of chances, the user still says yes, he has a car. Now we will try to understand other information from the user, from the audience, to dimension from the users. We will adjust the existing probability. This adjusted probability will be posterior probability. Now let me give some examples. So talking about the talking about the what is this? Talking about understanding posterior probability. First, let's understand what is probability. Then from there, we will try to understand what will be my posterior probability after understanding something else as well. So to understand that, first let's understand what is probability. What is probability? Probability is simply nothing but the chances of occurrence of an event. That is all probability you know all about. When someone asks you what are the chances that the match today will happen, or what are the chances that I'll get a head when I'm tossing a coin. Now let me open the void screen. Okay. Now someone is asking what are the chances that it will be a it will be tails if I toss the coin. Okay. What is probability? Probability is basically chances of occurrence of an event. So it is basically how, what are the chances that a particular event will happen. How it is calculated? It is calculated by chances of occurrence of an event divided by total possibilities of occurrence of events. I'll simply say divided by total possibilities. Now in this case, tossing a coin has only two possibilities. Let's write the possibilities. It can either be tails or it can be heads. There are only two possibilities, right? Now, talking about calculating the probability, now what we need to do is, to answer the question that the user is asked, we will see what are the chances of occurrence of tail if I'm tossing the coin. There are only one chances of tails out of two chances. So 1 divided by 2 will be zero point 0.5, which is also, which can be translated into 50% chances are there that if I toss my coin, there it will be heads or it will be tails. Now this is the idea behind probability, just the overall idea. The few key points that we need to keep in mind is probability is always between, it will be greater than 0 and it will be less than 1 or less than equal to 1. It can be 0, greater than or equal to 0 as well, both inclusive, 0 and 1 both inclusive. This is a general property of probability. Now, given this case, let's understand posterior probability. Now, let me come up with a question. Let's do this max in Excel. Mm, mm, we're gonna take this example. So let's take a new example this time. What are the chances that a person randomly identified owns a car? Now this is the question, guys. The question is very simple. Now we need to know what are the chances that a person randomly identified will have a car. Okay, this is the question. My I already have a knowledge towards this question. So what I'll say is the answer will be there are a good 15 or 20 percentage. Let's keep the maximum. There are 20 percentage chances that he or she might own a car. This is my and already existing belief or understanding. Okay, so what we will do is we'll conduct the experiment and find that this particular person, a particular sample that I've randomly generated has car. Maybe I can create a data and show you, that way it will be very easy to understand. Users having a car or not, yes or no, basically. Okay, let's take a data set. Well, these are the different users to whom we asked the information whether they have car or not. I'm going to generate the answers randomly. I'm not going to have any fixed method, so I'm using a random function to generate the output. Now we have randomly generated the answers from the different users. Now what is my already existing belief? My already existing belief is that only 20% of the people are having car. But after performing the experiment, I will try to calculate what is the probability and things. Now how many total incidences we have? Total users. We have 18 total users, right? If I'm not wrong. We have 18, yes. Out of which we need to know what is the probability of having a car and what is the probability of not having a car. So what I'll do is I'll calculate this. Probability of yes is 9 and probability of 9 also will probability of no also will be 9 then. Yeah. Then what happens here? If I have to calculate the probability, 9 divided by total number of events, the same happens here also. Here I'll just choose 9 divided by total. So here, what is the conclusion? The conclusion is that 50% of the people are having car now. Now, what is my existing belief? Only 20% of the people are having car. But after conducting the experiment, after collecting data and understanding more information, more dimension, we can ask the user, how come you have the car? He might say, I have additional income, my salary has been increased, I got promoted, my I bought a new land, and my share market gave me good returns. So there might be additional factors that comes into picture to change my existing probability belief. My existing probability belief is 20 percentage, but after conducting the experiment, I will change this belief into 50 percentage chances. So there are good chances that if I ask 2% randomly, one of them will definitely have a car. So this new belief after conducting new experiment and understanding more information about the user is called as posterior probability. The already existing belief without any experiment and things is called as prior probability. Okay, this is prior probability and this is posterior probability. What is the probability? The belief that I had becomes my prior probability, and after conducting an experiment, if my probability changes, then it becomes my posterior probability. This is the idea behind posterior probability. Now, what happens with bias theorem is that we have a prior belief that this is how much it will come. But after adding as many new data by conducting several experiments, then we will see a change in the existing probability belief, which is a prior probability. Then we will adjust the belief according to the new data and the output generated out of it. This adjusted information then becomes posterior probability. We will conduct this experiment on a very regular basis because everything is very dynamic in nature. Everything keeps changing in the current world. So you conduct this experiment repetitively. There is no place where you are going to stop this and wait for this to become static, because it will not the data can never be static. It will always be dynamic in nature. Let's understand what is total probability rule. Now, talking about total probability rule, first let's understand what is the theoretical understanding of it. Total probability rule, it is also called as law of total probability. It basically understands the probability calculations into distinct parts. When I say distinct parts, what it will simply do is, rather than calculating probabilities at one level, it will try to calculate probability at different dimensions and try to conclude with the output out of it. It is actually used to find the probability of an event A when you do not know enough about event A's probabilities to calculate it directly. Exactly, if someone is asking you what are the good chances that Rohit Sharma will score a century today, if you do not know enough information about Rohit Sharma, you will see what are the what are the bowlers who are going to bowl against Rohit Sharma. That way we will be able to understand how much runs he might score. If they are weak bowlers, there are good chances that he might score a really good he might score really good runs. But if it is a very strong bowling attack, then there are good chances that he might get out early as well. But since we do not know any information about Rohit Sharma, we have to walk around the other way and find what will be the probability of event A, which is Rohit Sharma in our example. Rather, you will take a related event B and use that to calculate the probability for A. I think this is exactly what we just spoke and had a discussion on. Now the probability of A can be written as sum of events B. The total probability rule is, if I wanted to calculate probability of A, it is very simple. I will calculate the intersection. This is not union, this is intersection. So probability of A intersection B plus probability of A intersection B without without intersection. This is with intersection and this is without intersection. Yes, let's see the rule with an example. See here. Yeah. Now the idea is, you think that your health issue is you are 100% fit. Now someone is seeing the doctor. 80% of the people are seeing the doctor. 20% of the people are not seeing the doctor. Okay, in this case, if I wanted to know what are the what will be the percentage of people who will have health issues, we do not have the information about this particular piece, because there are very few people who goes out and checks for health issues. But out of all the people who are going for health checkup, it says that 35% of the people do not have health issues. It means that Since the probability is always between 0 to 1, we can calculate probability of failure as 1 minus probability of success. That is what probability, total probability rule says. So if I substitute 30.35 with 1, it gives me 65. It very clearly indicates that 65% of the people have health issues. Even though they do not go to the, they do not go to the health checkup or anything, we can still we will still be able to understand the other side of the probability just by having one dimension. It can be probability of success or it can be probability of failure. We will be able to calculate the other way around. The same thing happens here. If I have to calculate the probability directly, total probability rule, it will always add up to 1. It always sums up to 1. That is the idea of probability. I'll show you an example also. In this case, 80% of people see doctor, out of which 35% do not have health issues. So that becomes the 28% probability. The question might be, what are the chances that a person who is visiting the doctor will not have health issues? There are 28% chances that they will not have health issues. Now, what is the probability that a person seeing a doctor will have health issues? There are 52% chances that that particular person might have health issues. Then what are the chances that a person will not have any health issues even though he is not visiting the doctors frequently? There are only 1% of chances that he will not have health issues. Whereas even if he is not seeing the doctor, there are good 19% of chances that he will have health issues. If we add all together, all the possibilities will accumulate to only one is basically 100 percentage, because the probability always sums to 1. That is the idea of total probability rule. Okay, let me show an example. Mm, Now let's have a question. What is the probability that a dice will roll to? This is my first question. Now, how do I calculate the probability for this? First, I need to know what are the individual possibilities. 1, 2, 3, 5, and 6. This is my individual possibility. Then let's go on to the total possibilities. 6. There are 6 chances only. So 6 is my overall total probability. Total possibilities basically. Then this is individual output. The chances of individual output is something that we need to keep in mind. Chances of individual output occurring when I roll the dice once, it should be 1 only for all the sides, because if I roll my dice one, only one side can be taken as output. So in that case, that becomes my overall possible chances. Then let's calculate the probability. Probability is chances of occurrence of an event with the total number of possibilities. It tells me I think that's to do. Let me just format this. Okay, now in this case, we have the values for each and every, each and every time the dice rolls. Let me put this in percentage so that we can see things. Or what I'll do is I'll keep it in numbers here. I'll keep it in percentage here so we can see the outputs. There are 16.7, basically if I round it, it will be 17% chances are there that when I roll my dice, it will give me the side 1. Then the same happens for each and every side. There are 17% chances that every side will happen. Now, what is the total probability? Total probability is basically addition of all the possible outcomes. This is what total probability rule says. If I sum all the total probabilities, total possible probabilities, it will always add up to 1. It will never be less than 1. It will always be 1. In percentage, it will always be 100. 1 is being 100%, 0 is being 0%. What is our range of probability? Our range of probability is 0 to 1. So it is very clear that any time, any dice, any event, not just rolling a dice, any event will always add up to 1. That is the idea of total probability, which always sums up to 1. This is the idea behind total probability rule. Maybe let's see one more example also. Heads and tails, tossing a coin. Okay, there are two chances that if I toss my coin, there are only two chances. Heads can happen once, tail can happen once. There are two possible chances. If I divide 1 by 2, it gives me 50%. If I add both, it gives me 1. So this is the idea of total probability. It tells me irrespective of whatever events that we play with, you will always have the overall probability as 100% being the maximum. You cannot have anything less than that. Now sometimes even though I said the range of probability is 0 to 1, let me quickly give one example to understand this better. If it is 0, it means that event will not happen. If the probability is 0, it means that the event will not happen. If it is 1, the event will happen. What if it is anything between 0 to 1? If it is anything between 0 to 1, we will directly consider it as probability of success. So we will say 17% chances are there for the event to occur. Now, what does total probability also says? If you know one dimension, you can calculate the other dimension. So, if 17% chances are there for it to happen, there are 83% chances that the event will not happen for the event. Okay, so this is the idea behind total probability. If I add everything together, it will be 1. Always it will be 1. Okay, so that brings us to the end of total probability rule. Let's see what do we have. Yeah, perfect. Recapping session. Now let's understand what we have learned in this class. We started with understanding what is population. Population is simply nothing but the whole data set. We will not do any partition in it. We will consider the entire data set for performing any statistical related work. Then what we will then talking about sample is whenever we have huge amount of data, when the volume of data is very high, what we will do is we will try to subset the data so that it does not cost us more time, resource and money. We will take the subset of the population, but we should always remember that the output generated by the subset of the population will be close to the population, will never be equal to the population. Okay, that is something that we must always remember. So there will be always some margin for errors since we are not taking the entire data set. But in order to reduce time, money and resources, it is absolutely fine to take a sample from the population. But the general idea is that if you have more sample, the more better it is for you to infer to the population. Talking about probability, probability is simply nothing but the chances of occurrence of a particular event. There are two important things that we learned in probability. One is posterior probability, another one is total probability theorem. Posterior probability is the probability that we generate after performing an experiment from the prior probability. And total probability rule simply says that the chances of occurrence of an event will always sum to 1 in an entire event, no matter how many times I do it, no matter whatever event that it is that I'm part of, the overall chances will always be added up to 1. With that, we will end our class for today. Thank you so much for joining this class. Please don't forget to like, share and subscribe to this channel. Thank you one more time.